And next up, I believe we have Daniel Silverstone from Codethink. He is going to give a talk, Integrating with Ease, Leveraging BuildStream Interaction with Bazel Build for Consistent Results. Welcome, Daniel.
Thank you. I'm afraid you'll have to ask me to bear with me for just a moment. Okay. Hi. I'm doing this a little bit differently to most people. Sorry for that. Okay. Hopefully you'll find this informative and interesting. It's a little bit different to some of the other talks that you'll have seen over the past couple of days. So first of all, who am I? I'm very new to the Bazel community. I've not met most of you before. I've been working on building software platforms for about 20 years. First as a Debian user, then Debian developer, then building platforms based on Debian and Red Hat, Pokey, rolled our own. Finally ended up working on BuildStream at Codethink, who are my employer, and in the past year or so making BuildStream and Bazel work together so that BuildStream can work well in a Bazel-oriented ecosystem. In the past, people who know about both Bazel and BuildStream have been asking me and my colleagues, why is one of them better than the other? Which one should I use? And instead, we've been saying, well, why can't we be using both? How can they work together to be better than either one could be on its own? So this is not about Bazel versus BuildStream. This is about Bazel and BuildStream working together to solve quite complex systems integration problems. So to give some context, at least from my perspective, Bazel is a build tool which tightly integrates the software components that you're building. It is rapid, it does its best to be correct as possible, excellent caching and remote build support, and an active and interested community. At Codethink, we've been working on getting the projects that we're involved with to be more aligned with Bazel and to use Bazel-aligned technologies where we can to solve systems integration problems, not just software build. So we need to define systems integration for the purpose of this talk. And for the purpose of this talk, we're talking about some basic platform software. Codethink mostly deals with Linux, so that's my focus for today, but this does apply to complex systems built on Windows, Mac OS, and so on. And for now, when I talk about a basic platform, I'm talking about a kernel, a libc, low-level userland software, so systemd, core utils, that kind of thing. To get anywhere, you're going to need tool chains. You usually acquire one from somewhere else. Then you bootstrap one that you can trust a little more, and then we add in more compilers, more languages, language runtimes. We get to middleware, so TensorFlow, GStreamer, domain-specific languages like automotive communications software, maybe X11 or Wayland if you're building graphical systems. And then you need to integrate your applications on top of that. This, again, likely includes a significant number of other libraries that you're dealing with, systems configuration changes, lots and lots of code. And this is probably where most of you guys are working at the moment. And then, of course, you have to deploy that. That might be Docker images, like we've seen. It might be disk images that are going to be installed onto hardware in factories. It might be over-the-air artifacts to update existing installed systems, writing an AWS Lambda. Most likely, it's some combination of all of these. So this leads to really interesting problems that require particular approaches to solve in order to minimize the cost both to systems integrators and to do this without making the lives of day-to-day developers worse. So we'll explore this with a small systems platform. And when I say small, I mean maybe 500 independent pieces of software that need to work in concert. They have different build systems. Some might be Bazel. Most are probably not. They have complex dependency chains. Each of those projects has got its own update cadence. The software might change. The dependencies may come and go. Changes in your dependencies may require updates in other dependencies. And all of this has got to be managed effectively in order to cope with the integration problem. And all of this needs to keep going over a product's lifetime. I imagine many of you are dealing with situations where your product lifetime is fairly short because let's say it's an app and you update the app and all your developers are working with that. All of your users just get the new updates. But something that I have to deal with quite a lot, many of my clients are automotive. And for the automotive guys here, you know that lifetime of a software product can be decades. Your integrated systems have to be updatable, reproducible across that lifetime. They need to cope with security updates that come in across that lifetime. They need to cope with changes in the customer expectations across that lifetime and still be effectively the same system. Also, your developers come and go. Your working environments for your developers for your product still have to be reproducible up to decades after you thought you were last finished with that product. Developer hardware changes, you may have to update for that. And all of this has to be done with minimal cost, minimal friction, minimal wasting of time. Integrators need tooling to help them do their jobs, automation to help them not have to do their jobs, and developers need the ease of developing work that can be easily integrated, to not have to care about that integrated tooling, except if it can also improve their lives. We particularly want to eliminate that, where it works for me, response, when you have issues. So we can scale this up. Large product development often involves many engineering teams. These are often distributed among companies, not just within one company. They have complex interdependencies between the teams. But for the purpose of this, we'll simplify it. We'll talk about platforms. Platforms need, again, potentially many teams, tool chain, operating system, middleware, etc. All of these teams are feeding into each other, and the output of this group is effectively your target base platform, your development platform, tool chains that perhaps Bazel might consume, that kind of thing. Their outputs are consumed by a putative applications team. Again, many of them may deliver into one another to aid in their own internal validation. And then they deliver on to a systems teams, and they're dealing with integrating everything together. They're dealing with the complex interactions between the various applications, their library dependencies, the platform on which it's being built, maybe the hardware that's coming in from some undescribed hardware team that's feeding into this. They have the ability to do the most complete testing of any of these groups. Therefore, they're likely to be feeding back then to platforms, applications, etc. And this is a massively complex mess of interactions. And we think there must be a better way to deal with this. Codethink clients are often organized similarly to this. We've been dealing with this for a long time. And out of all of that work has come what I'd like to talk to you a little bit about today. BuildStream is an integration tool. It uses any number of build systems, of which Bazel is perhaps the fastest, most correct. BuildStream targets the construction of software systems from embedded device firmware and IoT, server operating systems, automotive platforms, industrial logistics, blah, 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 blah. Tool chains that Bazel consumes is one kind of thing that BuildStream does a really good job with, and we feel that BuildStream is probably an excellent way for you guys to construct tool chains. It's a redo of an older internal project at Codethink that you may or may not have heard of, but I've promised not to speak its name. And BuildStream was started with an explicit goal of building a community rather than being a Codethink project. So if you imagine the Bazel community rather than Blaze, same kind of idea. BuildStream is here to work with other tooling projects, such as Bazel. Rather than trying to replace or outdo them, we want to work together. And BuildStream, we feel, can be used as a pretty good way to get to Bazel, when perhaps your software stack does not lend itself to being fully integrated into the Bazel world. Maybe you're currently using Yocto or something like that to construct stuff. We think BuildStream is a good fit. Started at the end of roughly 2016, initially to solve GNOME's integration use cases. So if you're familiar with that community, JH Build, GNOME Continuous, that kind of thing. It's now community maintained for those use cases. It was adopted to solve a similar problem to the GNOME problems, but for base platforms, the Free Desktop SDK project moved from Yocto and Flatpak Builder over to BuildStream, and they've been going from strength to strength with that. Free Desktop SDK provides toolchains and platforms to build systems out of Linux and another large collection of other free software, and we'll be using some of their outputs in, hopefully, assuming they work, some live demos as we go. But can we go bigger than this? GNOME and Free Desktop SDK, 700 to 800 independent components. We presented this at GUADEC, a GNOME conference, and one of our clients invited us to come in and see what we could do with their use cases. A team was spun up, including myself, that was focusing on the performance and scaling up of BuildStream. And BuildStream is now running in their use case with hundreds of thousands of components all at once, the full gamut of build systems, including Bazel. And by adopting technologies from the Bazel community, particularly CAS and the RE API, BuildStream is integrating with a horizontally scalable Bazel-compatible infrastructure. Enough adverts, let's talk tech. A BuildStream project is probably fairly similar to a Bazel project in the sense that there's lots of pieces of software involved, and we're interested in how they fit together. But BuildStream focuses on each piece of software only as an integral component. We don't try to look inside it, and we focus on the interdependencies and how they integrate together. You have a project configuration file. This is called project.conf. It's YAML, and it has fundamentals like the project's name, where the inputs are located, configuration options for the project. This is a little bit like Workspace. BuildStream splits the inputs that it's dealing with into two things, elements and sources. Elements are integral pieces of work to be done. That might be a software build, it might be an integration step in producing your output. And sources, which are sets of inputs that come together and get staged as the input to an element process. Then there are the dependencies. Just like the Bazel action graph, BuildStream elements form a directed graph. Dependencies are arcs in that graph. So A build depends on B, build depends on C, does the obvious C builds, then B builds, then A builds. Dependencies can be runtime or build time, or both. So these arcs are annotated with the kinds of operations that apply to them, and then different operations within BuildStream at different times are going to follow those arcs differently to produce different work actions. And it's elements all the way down. Elements represent both integral pieces of software and also integrations of software. And we can join these together, so like how Bazel offers remote repositories and the like, BuildStream has this, it calls them junction elements. They're semi-special because they're handled by the loader rather than by the main build machinery. Again, a bit like a repository rule in Bazel. And the staged sources that come out of a junction are another BuildStream project, and that project's elements are made available to the project that you're building. Just like labels from one repository are available in another. So let's look at one of these elements. This is an element from Free Desktop SDK. It is libjpeg turbo. It uses CMake to build. And Free Desktop SDK put this into toolchains and platform systems alike. The first thing that we kind of notice here is the kind marker. Actually, this is YAML in case anyone hasn't noticed that by now. BuildStream's behavior comes mostly from plugins, and kind just selects the plugin to use. Then we have some dependencies, runtime and build time. The first Bootstrap import is both. The other two are just build time dependencies. The distinction is kind of important. You don't need CMake to use libjpeg turbo, so there's no point having that in dependency chains. And since all of this forms a graph, elements can be depended on in different ways at different points. Since elements are used as deployment outputs, you can end up with these things in all sorts of contexts. So the Bootstrap import in Free Desktop SDK, this is pretty similar to what in Bazel you think of as a toolchain. It's an import of a basic system that's capable of compiling code. And from here, all of Free Desktop SDK bootstraps within sandboxes. We also bring in CMake. And by dint of the way that build dependencies work, all of CMake's runtime dependencies. And we bring in NASM, presumably there's some optimized code in there, and all of NASM's runtime dependencies. All of these elements and their dependencies are tracked, and the inputs are known so that the output identities can be computed. This is similar to, but distinct from, Bazel's approach. Next, we have the sources for the element. Here, there's only one source. The source is coming from GitHub in this instance, and this is just a little example of the way that BuildStream deals with URLs. We have URL rewriting, so you can have a little prefix, and that prefix is defined in your project config, and this lets you have a mechanism of saying, hey, I've mirrored all of our GitHub dependencies onto an internal Git server. I can just change that GitHub prefix to something else. All of the element files stay the same, but the content has come from a different location. Ref means the actual identifier of the actual source that is going to be built. In Git, that's pretty obviously a char. Git tag, this plugin uses a git describe-like format because it will then put a tag down at the right point to give you git describe capability within your sandbox. And this is akin to like a Merkle root, a digest of a Merkle root for the source. It's used to identify the inputs as part of the calculation of the caching key, which is similar to how Bazel constructs an action. And finally, just because this is quite a cool bit of BuildStream, we have a concept called source tracking. And here we're just saying track the master branch of this repository, and when instructed, BuildStream will go and fetch the element source, ask the source plugin to perform a tracking operation. For git tag, that's a repository refresh, and then looking at the tracking branch to see if it's changed. If it has, the source plugin updates the ref. After all of the sources for an element have been tracked, remember that that's a list, but it's only got one element at the moment, BuildStream will rewrite the element file to update those refs, and then you've got a diff that could be applied. Automating this process leads to speculative updating of your software platform itself in CI pipelines. Your CI pipelines could run a build of that project and then offer up merge requests, offering validated tracking changes to your dependencies. And this is one of the things that massively reduces the workload on those integration teams. So let's explore a project, see how well this goes. Is that text big enough for people? Yeah? Cool. So here's a BuildStream project. As promised, we have a project.conf. So we've got a project name, some information about what input format version is required for BuildStream to be able to process this, some aliases for dealing with Free Desktop SDK, a whole bunch of variables, plugins, the kind of thing that you'd expect. We have a bunch of these elements. Element files end.bst. This is not just convention. BuildStream will be very sad if you don't end your element files.bst. And this is partly because then we can do nice things like tab completion in a useful fashion for you. If we have a quick look at one of those elements, this is a GTK application. It actually happens to be built with Bazel, which is quite cool. That's interesting. This format's doing rather nicely. Never mind. There's a bug there. One sec. That path is very wrong. So I'll just fix that. OK. Actually, while we're here, let's do something a little bit more fun. BuildStream has the concept of workspace. Workspace in BuildStream is just something where you can say, hey, I want to work on this file, this element. I want to come to it and decide, make a change maybe. Right, there we go. So I've now got the source to that around. let's have a go at... This is a really complex application, as you may have noticed. Someone give me a name. Yell one out.
Joe.
Beg your pardon?
Joe.
Joe. Cool. I'll tell you what, we'll just build this. Giving a little bit away about what's going to happen. So this is going to integrate that changed application with that little bug fix that I made to the element into a bootable image, which is then going to go ahead and be hopefully usable later on. And you can see here that BuildStream has started running that build, and it's kicked in Bazel. So we'll come back to that a little later. There are some limits to this. BuildStream is very POSIX at the moment. It really only works on Unixy operating systems. It does work on WSL with remote build only using RE API. And that's mainly due to the fact that BuildStream needs Fuse in order to do its sandboxing. macOS is similarly limited at the moment. It will work on WSL2, we fully expect, and work is underway to enable more different sandboxing tech to try to reduce these limits. BuildStream is primarily focused on native build. It can be used to cross-build. If you're crossing architecture in the same operating system, then the Free Desktop SDK project actually provides cross-tool chains. You know, x86 64 to ARM 64 is pretty simple, but its primary focus remains native build. And this is in part due to experiences we've had where cross-building ends up needing significant patches to large numbers of open source projects. Those patches are often not accepted by upstream. I'm sure all of you have had that experience in the past. And this leads to a high cost of manually reintegrating changes on every upstream change. You can still use cross-compilation toolchains as part of a project. So for example, we have projects where you're building a system for x86, and as part of that, you need to build firmware for an embedded controller. That's obviously a pretty simple task. BuildStream has stringent sandboxing, by default, full stop. This means that your sandboxes have no content from your host. This means that it gets a little bit difficult to reuse intermediate artifacts from the middle of a build. Although, again, this is being worked on, particularly because we want to enable Bazel to access its intermediate artifacts and to access an RE API so that it can not only have been distributed, but then distribute its own work. BuildStream names its artifacts based entirely on the identity of the inputs. As such, it can label its entire build graph without doing any work to compute any of its output content. And it can know if it already has that final output pretty quickly. Bazel, on the other hand, names its outputs based on their contents. So it has to compute each output in turn. Obviously, that can be cached and stop, but it gets to stop as soon as it detects that this change is no longer propagating through the action graph. Both approaches have their benefits and their drawbacks, and so by combining the two, we're hoping to mitigate the weaknesses of one and amplify the strengths. This slide, I feel, got stolen by the previous talk, but let's bring Bazel in. That's why we're here. BuildStream is already sharing technology with Bazel, the RE API, and the CAS, but let's make BuildStream integrate Bazel itself. To do that, we wrote a Bazel Build element plugin that understands how to run Bazel. Just like C and C++, we need a bootstrap version. I've elided the other bits and bobs that this needs, but ultimately, we need an import of Bazel in order to build, in this case, Bazel. So this lets us get a rebuild of Bazel done in the sandbox. The target label, fairly obvious, tells us what we want a Bazel build. And BuildStream lets us override command sets in elements. And so this just says, hey, to install Bazel, we just want to grab the Bazel binary that's come out of the build, and we want to grab the wrapper script and put it all together in the target binary directory. For any Bazel built project, including Bazel itself, you obviously need a number of sources. First of all, the source of the thing to build. This is 1.1, sorry. We will get to 1.2. and a patch that fixes a name clash in unistud.h. The patch comes from the project tree. So that directory that I showed you before had a patches directory, and that has that patch file in. This just adds a local file from the project tree into the element sources. In this instance, this is a C-query output. It's avoidable if you must. The host, so the Bazel Build plugin can use the host Bazel to work out what your dependencies are, but that's painful and leaks host information. So we generally recommend that you use this. If you do this, then effectively your C-query output is being tracked like a cargo.lock or a gemfile.lock if any of you are Rust or Ruby people. This improves the completeness of the sandbox for reproducibility. We then wrote a new source kind, which consumes that C-query output, finds and fetches all of the sources, stages them into a directory so that bazel-dist will do the right thing. And this is really important because, like I said, the sandbox is quite stringent. Bazel won't have network access from inside that sandbox by default. So let's look at that. And hopefully it will work again. Ooh. Tell you what, let's get another terminal. I should have thought of this and made a second one. Can anyone see that menu? It's so tiny. Hooray, right. So the Bazel element, we saw, I said I'd elided quite a few dependencies. Bazel needs quite a few things in order to work usefully, including a JDK, obviously. And there's its installation commands and its sources. There's your Starlark manifest. This is loaded by that source plugin and does all of the right things. And this is it's just data as far as BuildStream is concerned. So let's pop back again. These are two tools. They work in a similar problem space, but they have a different fundamental approach. They're both designed to work with other tooling, but they've been done somewhat in isolation from one another, and so we see lots of opportunities to use one of them to overcome problems with the other. Bazel likes to use the network quite a lot. It seems to expect network access for quite a lot of the operations that it will be performing on the host, which of course leads to difficulties in controlling the environment that Bazel runs in. One of BuildStream's strengths is in highlighting whenever you're accidentally doing this because of the strict sandboxing. And so by using BuildStream to run Bazel, we benefit from both BuildStream's strong guarantees on its inputs and Bazel's strength in actually handling the software build that happens. There can be quite a high computational complexity of determining the sources associated without risking untracked changes. So when preparing the plugins for BuildStream, we needed to determine all the inputs that are required for a Bazel build. So there's workspace, there's Bazel RC, there's extra command line arguments. It gets to be quite a pain. And really, it shouldn't be the system integrator's job to do this, which is why we came up with that use of the C-query output. With the C-query output, combining with BuildStream, we can isolate developers, and we can use BuildStream to safely track all of the inputs, regardless of whether or not it's just a version number or it's a SHA sum in the workspace. And we can therefore ensure that we will replicate the same build over and over again. That was obviously one way that we can integrate, but we can also use Bazel to use BuildStream. Why not? Rulz BuildStream is the obvious word that you were probably looking for. It's an evolving integration effort where BuildStream is used to make a tool chain, and then that tool chain can be used to build software with Bazel. Bazel is driving all of this, making it easy for your Bazel developer. And we are improving this over time. I think what I'm about to show you is not at all what we would like it to be finally. We are working towards offering this up to the Bazel Build project on GitHub. We've had some talk about this. And again, this consumes Free Desktop SDK. If any of you are familiar with Rulz Nixos, then you might recognize this kind of approach to things. So let's take a little look. Here's an example workspace file. It's obviously not the entire thing, but representative. We need to load in the BuildStream repository rules, set up a repository reference. Now that is to a BuildStream project. So that's literally just like the project that we've just explored. There's a bunch of elements in there. At least one of those elements is going to be the toolchain that we care about. Free Desktop SDK has all of these, so we're just using that. Then we need a way to consume that project. So BST element is a rule to build a BuildStream element, fairly obviously. And then our project is going to need a build file, the usual. And we need to constrain the platform to something that matches the toolchain that we're going to construct out of BuildStream. We then need to configure Bazel to use all of this. We could use the command line. That's Bazel RC. Constrain the platform according to the options that we picked in the build file. And then tell Bazel where that will turn up and how to use it in the final build. Of course, we've got to actually put that together and run Bazel. So we give it an fdsdk config. And we need to set this because otherwise Bazel gets very sad when it can't find a compiler on the host, even when it shouldn't. But it's pretty easy to have that in your environment. Let's look at that. So I have a BuildStream project here. It's got a workspace that's using Rulz BuildStream. We have a simple hello world again. I won't take a name from you this time. We'll just go with hello world. And let's do a BST build. Is it dash? I can't remember. No, not BST build. What am I talking about? A Bazel build. That will work better. I'm embracing failure, guys. So I've actually got that environment variable just set on login. And so it's not going to work because there's no toolchain. You could have made this your default, but I just wanted to demonstrate that I wasn't cheating. There is no toolchain there. So let's ask Bazel to build this. I've deliberately done a Bazel clean -- expunge. This is the beginning developer experience, as it were. This means that Bazel has to ask BuildStream to construct the toolchain. It is slowly going ahead and doing that. Obviously, once this is completed once, you've got that in your Bazel cache. There's no worries. It looks like we're almost there. It's just checking out the toolchain to hand it over to Bazel. And now Bazel gets to do its build and succeed. And if we change that build to a run, then we can obviously run it. Cool. Oh, yeah, thank you. I hadn't forgotten. We did an integration, didn't we? How was that going? Right, that's completed. We now have a VM image sat there to use. Can I pull that locally? So I'm doing this in virtual machines to try to say integrators, developers. Unfortunately, my virtual machines can't run virtual machines. I haven't got that powerful a system. So I'm just going to drag this locally. It's so slow. There we go. Give me a moment. Somewhere over here, I have a magic command. This is my virt manager. Oh, goodness me, it's tiny. Where's the play button? There's the play button. As I said, this is derived from Free Desktop SDK. And with a bit of luck, that's just going to do its thing and give us an integrated system. And again, where's my mouse pointer? There. Hey, Joe. So, recap. Where are we? What would I like you to take away from this? BuildStream and Bazel occupy very similar places in the software ecosystem, but while they both integrate a large number of inputs into a usually smaller number of outputs, each takes a fundamentally different approach. BuildStream components are integral black boxes. The component build systems are in violet. We have extremely strict sandboxing with the identity of the outputs derived from the identity of the inputs ahead of time. Typically doesn't require invasive changes to a component in order to adopt it into a BuildStream project. BuildStream knows immediately on loading the element tree if it's already finished, and even if it's missing intermediates along that way, that doesn't prevent it from knowing it's finished. But BuildStream cannot short-circuit that build. Bazel typically is diving inside the components. It's reasoning about all the moving parts at once. As a result, you've got to kind of rewrite your build system into Bazel rules. Yes, foreign CC and obviously Rulz BuildStream demonstrate this isn't always necessary, but by doing this, Bazel gets a really deep understanding of the build graph. Bazel, by naming its outputs after their content rather than after their inputs, gets to short-circuit builds, but it may have to reason the whole tree forward from a change in order to know that nothing has to be done. Missing intermediates may have to be computed. But as we've shown, by working together, we can get some quite powerful outcomes. And while we are working on bringing these things together, it is still a work in progress. We are continuing to work on it. We would love to see some of you join us in working on it and to make this integration work better for you. I hope that you'll all agree that by solving the problems of component integration in subtly different ways and at two different levels, Bazel and BuildStream complement each other really quite well. By using the two together, you don't have to immediately adopt every dependency fully into Bazel, which will reduce your maintenance burden if upstream don't want you to shift, but retains the option of integrating really tightly when you need to. Both use the RE API and CAS for caching. Bazel's RE API action cache and BuildStream's artifact service are somewhat different because of those naming constraints, but all the individual components of the builds are being shared. Work on BuildBox, which is the sandboxing technology that BuildStream is using, is going to lead to Bazel being able to access its RE API from within that sandbox in a constrained and controlled manner. And that sharing, therefore, will become even more powerful. By sharing the work outcomes, we have reduced cycle times, both for integrators and application developers. And we have both teams benefiting, I say both teams, integrators and application developers benefiting from CI pipeline outputs. One thing that perhaps wasn't completely obvious there, the toolchain that Bazel built and used was exactly the toolchain that was built to build Bazel in the other virtual machine. They are shared, they're the same elements, and so you absolutely know that your developers are using the same toolchain as your integrators are using. This leads to fewer, that worked for me, situations. Application developers can be confident that their validations are going to hold during integration. Integrators can be confident that their applications that they're receiving from their apps teams are going to behave properly when they're in situ, when they are integrated into a build. Deployment teams can be assured that that integration is extremely likely to succeed. Thank you very much, and I encourage you all to have a look at that wiki page. It's got links to all of the other things that I've referenced during the talk.
Thank you very much, Daniel. I appreciate it. Of course, you know the time. It's time for questions. Super interesting talk. You are the only brave one that did the demo.
Tried to get some failure, but it all worked, sorry.
You know, sometimes it works out, right?
I even deleted my VM this morning to try and cause problems.
Okay.
Hey, Daniel.
Hello, Finn.
Hello. So I'm Finn. I'm a freelance build and software engineer at the moment. So I'd really like to use BuildStream. I think it's a great tool. One question I had about toolchains. Can I construct any sysroot with BuildStream, and will Bazel just be able to consume that toolchain?
Right. It's not quite that simple at the moment.
Right.
Because of the way, particularly, that GCC is not directly relocatable, this can be a problem. We are working on some extra rules that construct wrappers so that that all works. As it stands at the moment, if you follow the instructions that we have on that referenced wiki page, then As long as everything's relatively next to one another in the right ways, it'll all work. At the moment, I can't say better than that.
Okay. Thank you. I think that's really great work. Another question I had, you said about the BuildStream using the remote execution API. Does that mean it's compatible with all of the remote execution servers, or is it only compatible with the subsection?
This is an ongoing bone of contention with the RE API community. BuildStream, because of the way that it does sandboxing, is giving a whole system to the RE API server to run. Many of them don't like that. In addition, the file system that BuildStream has offered up has to be made to be the root of the build. That can cause problems with some of them. I think at the moment, BuildGrid works fine for it. We had an experiment with RBE. I don't know whether that's got any further. And I know that we have a project at Codethink validating remote execution implementations and remote execution clients and their interoperability. If any of you were yesterday in the Lightning talks, then you might have seen the talk by my colleague Josh about that. That would be the place I would start to work out what the interoperability is like. Hopefully it will improve with time. We will see.
Okay, thank you very much.
Thank you. Have I gotten away with only one question?
I think it has something to do with lunch and rumbling bellies. So I just want to give you another round of applause. Thank you, Daniel.
Thank you.